Hello friends, this video on relations and functions part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched relation and functions part 1 to part 3. Let's see a new term called relation. Actually, we have seen this term relation. We have discussed that relation is nothing but a relation or a rule between objects. For example, when we say father and mother, I told, student and teacher, husband and wife. So these are the examples of relation. So we have cleared the concept of relation. You know what relation is. Now we'll discuss relation in terms of Cartesian product. So relation is nothing but a subset of Cartesian product. Relation is nothing but a subset of Cartesian product. Please note, subset is a very crucial word. Relation is a subset of Cartesian product. Relation is a subset of Cartesian product A cross B. And that subset is derived by describing a relationship between A and B. Because we can have n number of subsets. So to create a subset, we should have a relationship. This is the relation which is following. Have this example A and B. A has element A, B and C. And B has element Amit, Bittu, Bholi and Dawn. The relation here is first letter of element in B. The first letter of element in B should be A. So Amit to Bhimu is a relation. A to Amit is a relation. B to Bittu is a relation. B to Bholi is a relation. And C to Dawn is not a relation. D is not there. So this is the we see in this case when you say A B when you say A cross B, you'll get n number of products. For example, A comma Amit, correct? A comma Bittu, or you will say A comma Bholi, or you will say A comma Dawn, and you will say B comma Bittu, B comma Amit. If you keep on doing, you'll find so many sets. But when you say relation, you are taking a subset of this. And to create a subset, we should have a relation. So in this case, we are saying the relation is that the first element of B should be element of A. And that's why we have created a relation. So in this relation, the relation will be A comma Amit. This is 1. B comma Bittu. This is again another relation. B comma Bholi. These are the only 3 values in this set. And this subset is a subset of the bigger set. That is, this is a subset of A cross B. And this is nothing but a relation which is bounded by a relationship that is first letter in B is equal to A. Relation is nothing but a subset of Cartesian product. To create a relation, to create a subset, there should be a relationship between A and B. So here we see between A and B there is a relationship, and the relationship is that second element, the element in B, for the elements in B, the first letter should be element of set A. Let's learn some terms in relation. There is a term called domain. Domain is a set of all first elements of the ordered pair relation. For example, in this case, when we say the relation was A comma Amit, because A is going to Amit, B is going to Bittu and Bholi, and C is not going anywhere, and D is also not pointing anywhere. So the relation was A comma Amit, B comma Bittu, B comma Bholi. That's it. So in this case, whatever it comes in the first element of the ordered pair is called domain. So here you note A and B is domain. Please note C is not domain, because for C there is no element in the ordered pair. In ordered pair we don't have C. So domain is only for those inputs we are getting the output. That case, it's a relation wherein there should be a relation between A and B. So in case of C, there is no relation between A and B. Similarly, range is also all second element in the ordered pair. Ordered pair is must. So here also, if you see in the ordered pair, we have Amit, Bittu and Bholi only. So only these three are range, and dawn is not part of range. As we have done for domain, A and B were domain, C was not domain. Similarly, Amit, Bittu and Bholi is part of range and dawn is not part of range, because these are the second elements in the ordered pair. And you see dawn is not part of ordered pair. Please understand, in domain you should not take all the elements in set A, and in range you should not take all the elements in set B. Only those elements which are part of the ordered pair should be taken. So here A and B was a part of ordered pair, so we took A and B as domain. Since C was not part of ordered pair, so C was not taken as part of domain. Similarly, for range, you should not take all the elements in B. Only those elements of B which are part of ordered pair is part of range. In this case, Amit, Bittu and Bholi is part of range and dawn is not part of range. So we have one more term called codomain. Codomain is the whole set of B is called codomain. The whole set of B. Here Amit, Bittu, Bholi, dawn, everything is codomain. Just learn this term. Codomain is nothing but whole set of B. So we say something like domain range or domain codomain. So domain is always on the left hand side. So it includes all the elements which are part of pair, ordered pair. Range includes all the second element of the ordered pair, and codomain is all elements, irrespective of whether it is paired, ordered pair or not. All the elements of B is part of codomain. So you can learn like this: domain range and domain codomain. When you say range, you say all the elements of part of ordered pair. When you say codomain, you include all the elements. And when you say domain, you say all the elements which are part of set A and part of ordered pair are part of range. Relation representation. A relation can be represented by roster form, set builder form or arrow diagram form. We will go through all this thing. Roster form, it can be represented in roster form also, set builder form and arrow form. Roster form we have discussed. For example, when we say A, Amit, right? This is one set, B, Bittu and B, Bholi. So this was the example of roster form where all the elements are listed. Set builder form, when you say X cross Y, then you can say XY where X is member of R and Y is member of R. Such kind of representation can also be done for relation. An arrow diagram we have discussed this way. There are two sets A and B. This has element A, B, C, and this has Amit, Bholi, Bittu. So in this case, we can create a row diagram. Such kind of representation called arrow diagram. Let's take one problem here. So we have a set A which has 6 elements 1, 2, 3, 4, 5, 6, and we are supposed to draw a relation from A to A, XY, where Y is equal to X plus 2. In this relation, we are asked to draw an arrow diagram and we are also asked to create a set builder form. Also, we are asked to write the domain, codomain and range of R. So now let's see, we create X and Y. X can have elements 1, 2, 3, 4, 5, 6. Correct? Now Y is equal to X plus 2. So it is 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. 5 plus 3 is 8. 6 plus 3 is 6 plus 2. 2 plus 2 is 4. Sorry. 3 plus 2 is 5. And 4 plus 2 is 6. 5 plus 2 is 7. And 6 plus 2 is 8. So when we see that 6, 7 and 8 are not part of A because X and Y both are part of A, so we can ignore this. So the only set we have is 1, 3, 2, 4, 3, 5 and 4, 6. So this is the example in roster form. Now when we are supposed to create arrow representation, we can create two box like this, and in this we have element 1, 2, 3, 4, and here we have 3, 4, 5, 6. And we can keep the element 1, 2 here also, and we can keep the element 5, 6 also here. But these are not linked. So 1 is linked to 3, 2 is linked to 4, 3 is linked to 5, 4 is linked to 6. This is set A, this is set A. A has element 1, 2, 3, 4, 5, 6. B has element 1, 2, 3, 5, 6. But these are orphan, these are orphan. Now we are asked to write domain. So domain, if you go by this, it says elements on the left in the Cartesian product. So on the left we get is 1, 2, 3, 4. So we can say domain is 1, 2, 3. Also from the diagram you see all the elements which has some values in this right side are domain. So 1, 2, 3, 4 are the only elements which has value. 5, 6 are not having any value in the right side. Similarly for range, all the elements on the right side of the Cartesian product. So Cartesian product is 3, 4, 5, 6. This side are the values. So 3, 4, 5, 6 are the values which are on the right side on the second element of the Cartesian product. And from the diagram also we see all the elements which is in the second side, this is coming from the first side. There is an arrow representation. So here for 3, 4, 5, 6 there is an arrow representation. It has some values in A, but for 1 and 2 there is no link between A and B. So we ignore 1 and 2. So range is 3, 4, 5, 6. When we are talking about codomain, codomain is nothing but all the values that are there in this set. So in this set the values are 1, 2, 3, 4, 5, 6. So the codomain is 1, 2, 3, 4, 5, 6. I hope this is clear. So what we have done, we have found x and y with the rule as told, y is equal to x plus 2, and then we found that 7 and 8 is out of range, so we ignore these values. So we have got this 1, 3, 2, 4, 3, 5 and 4, 6 pair. So this is our pair. We have represented the same thing in the arrow diagram form, and we have formed domain. Domain is all the first element of the Cartesian product. So the first element is 1, 2, 3, 4. Range is all the first element of the Cartesian product, that is 3, 4, 5, 6. And codomain is all the elements of the second set, that is 1, 2, 3, 4, 5, 6. On the arrow diagram also we can find domain and range. Domain is any element on the left hand side for which we have output, for which we have a reference in the second hand side. Similarly for range is any value on the right hand side for which we have a reference in the left hand side. So this solves out the problem.
Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.